Hi, my name is Anthony. I'm joining you from London today, and I work as a tech lead at Coinbase. And I'm mostly focusing on money transfers within Coinbase, so everything that moves money out of Coinbase into Coinbase and within Coinbase is handled by the team that I'm leading. And today I'm going to share our journey of picking, adopting, and scaling Cadence at Coinbase. So, financial transactions at Coinbase. Coinbase is the most trusted cryptocurrency exchange in the world, and we don't take this promise lightly. We always ensure that our customers are whole whenever it comes to processing their financial transactions. So should there be any failures along the way, we need to either find a way to complete that financial transaction or roll funds back to safety when the customers are refunded and the funds are placed back into their accounts. We cannot allow any stuck transactions. We cannot allow any double debiting, double crediting, because we're handling other people's money. People tend to get very nervous when there are issues with their funds. So this puts an extra pressure on our teams to deliver this. Financial transactions, in essence, are what is known in computer science as distributed transactions. So you take a single business process and you scale it across multiple different services that need to interact with each other to implement this business process. And you have a distributed transaction on your hands. There are a lot of things that can go wrong there. You have network failures, you have system failures, you have server outages, you have third-party failures, and you need to find a way to be fault tolerant in this scenario and always predict things that can happen and also be able to react for the things that you just didn't know could happen and find a way to resolve any issues this way. Quite early on, we've adopted a pattern that is known as distributed sagas. You can find it online. It's quite well known. We implemented it using our homegrown engine. But after a few years of running it, we saw some cracks in it, and it wasn't flexible enough to support more and more complex use cases that are being thrown our way. So we had to find a replacement for it. We started looking and quite quickly stumbled across Cadence. And after a few discussions with the Uber folks, we were convinced that we should give it a go. Back then, our primary alternative was AWS Step Functions. And our infra team was already using it to power our deployment pipelines. So it was a really good candidate. However, it suffered from exactly the same issue our homegrown engine did, which is it uses a declarative workflow format to define these workflows. And that was very inflexible. That was something that didn't allow us to implement more and more complex use cases. So this is why we decided to give Cadence a go. After a few weeks of setting it up, putting it in production, we had a simple setup that we could run load tests on and figure out whether it's a good fit. We don't have any Cassandra expertise in-house, so we ran MySQL database as the backing store for Cadence. And with our simple setup, we were able to achieve about 100 workflows a second run on a single cluster. And that back then was pretty much all we needed. And we were quite happy with using Cadence, and we decided to go ahead. First challenge was, of course, the lack of Ruby SDK at the time. But because we liked Cadence so much, we decided to implement it ourselves. It's a bit challenging to implement an SDK because there is a fine interplay between the SDK and the Cadence service to achieve this magic that Cadence promises. However, after a few iterations, we were quite happy with what we ended up with. We open sourced this as a Ruby gem. You can, there's a GitHub link on the slides. You can visit that. We focused on clean API and ease of use, kind of akin to Ruby's spirit of things have to be readable, things have to be quite easily understandable. Today, it supports most of the features that Cadence has, and we've been running it in production for more than 2 years now. And it recently withstood the kind of full load of the crypto bull run. So that probably speaks for something. We're quite confident with that. If you want to try it, go ahead, jump in, the water's fine. If you want to contribute, this is also very welcome. So open an issue or raise a PR, GitHub. Here's an example of what that looks like. Again, the aim here is that for that to be human readable. Hopefully we've achieved this. This is a fictitious example. However, it's using the distributed patterns approach. And it's actually not very different from how we encode our financial transactions at Coinbase. So hopefully this example gives you a bit of an understanding of how things work internally. The migration process itself was quite easy. We basically took all the existing business logic that we had and wrapped it up in Cadence activities, putting a very lightweight layer of workflows on top of it. We've put this everything behind a feature flag, basically switching from running Cadence or the legacy engine. And after we were happy with the outcome, we were able to progressively crank it up to 100% and never went back. We shared this use case across the whole company and got quite a lot of interest from other teams willing to try Cadence for their own use cases. So at the time, we decided to go with the vertical ownership model of Cadence clusters, partly due to the resources constraint. We were struggling to get kind of enough people. This gave us a really good isolation. So basically, in this model, every team would own everything from their service to the Cadence cluster that supports their use case. And for every new use case, we would add another Cadence cluster. The isolation was a really good benefit from this arrangement. If something went wrong on one cluster, that wouldn't affect the others. And that was quite beneficial for us because we were just ramping up on the operational expertise. In order to support teams that were running Cadence clusters, we've established a Cadence Council, basically a group of people who are knowledgeable about Cadence, and we would be able to answer any questions they might have and give them guidance on how things should be working. This is the diagram of the vertical ownership model that we went with. Basically, each team owns the full vertical. Came 2020, and with that came a massive increase in production traffic for us, hitting all of our servers, not excluding the financial transactions. And we had to go from the initial 100 workflows a second that we kind of budgeted for to about 1,000 workflows a second. And that was quite challenging. The vertical ownership model kind of gave us some initial time because we didn't have to handle the sum of all the use cases on a single cluster. That was naturally partitioned across all the different clusters the teams were running. However, we had quite noisy clusters, and the first thing that we did, of course, we maxed out our database. We put whatever AWS could offer us, which was 24x large RDS monster. That got us to about 300 workflows a second, which was a far cry from 1,000 that we were targeting. So we knew we had to do something extra. At the time, Cadence did not support multiple SQL databases within one cluster. It supports it today. But because it didn't support it back then and we didn't have a lot of time, we essentially came up with a solution to do client-side sharding. So on the client, where you would normally talk with one Cadence cluster, you would make the client aware that there are multiple Cadence clusters forming a supercluster, so to speak. And based on the workflow ID, you would route requests to one or the other. Quite simple solution, but gave us horizontal scale, and we could add the new Cadence clusters quite easily to the supercluster. Because we also persisted the workflow ID to cluster mapping, we were able to scale it up and down as we went. So we didn't have to sustain any outages when we had to scale the cluster up or down. This is not a recommended solution by any means. This is something that we had to do given our time constraints, but I think it's also a testament to how flexible Cadence is. We also switched to using the horizontal ownership model. We established a small infra level team that was now running and owning all of the Cadence clusters. That helped quite a lot with the new teams joining, because they didn't have to build this expertise to run a Cadence cluster, and they can just focus on the product and use Cadence rather than also maintain it and host it. As one of the future steps, we're looking at implementing MongoDB driver, because we have quite a lot of expertise with that. And hopefully with the Uber's help, we'll be able to do that shortly and leverage this. This is the diagram of how client-side sharding worked for us. So you can see that basically we're just proxying between multiple Cadence clusters. There are a couple of things I wanted to emphasize kind of throughout this process. Hopefully it will help you to go through the same process as well and not make some mistakes that we did. Start with this champion use case. That is how I prefer to do things. You just essentially find the use case that would benefit from Cadence the most. You implement that, and then you use this to drive buy-in into using Cadence, rather than going prescription and forcing everybody to use Cadence in the company. I just prefer this approach more than others. Really focus on understanding configuration and monitoring of Cadence. This is not trivial, and this is quite crucial to make sure that things don't get wrong. There are quite a lot of subtle signs that might show that your cluster is not healthy, and being able to spot them will prevent quite a lot of system outages. Also, there is quite a lot of rope for engineers to hang themselves by writing workflows. You have to make sure things are deterministic, timeouts are not trivial. Introducing breaking changes is also quite, can be challenging. Our solution to that was basically a very diligent PR review process, where people who know this stuff would advise others on how to construct workflows, and basically publishing dev guidelines and holding sessions. Also, scale can come at any point. Make sure to think about your scaling strategy up front. This is it from me. I know it was a bit rushed, but if you have any questions about Ruby SDK or how Coinbase uses Cadence, feel free to reach me on Twitter, GitHub. Here's the link to the Ruby SDK. Feel free to try it. And you can also find me on Cadence's Slack as Anthony, and there's a dedicated channel for Ruby SDK. Thanks, everybody. Thanks, Uber, for hosting me. And I think next one we got Alex from HashiCorp.